In lesson 8.2, we'll be talking about the areas of triangles, trapezoids, and kites. I believe that this first word here was supposed to be triangles. Sorry about that. And so if we look at the area of a triangle, as was stated in the previous lesson, we know that the area of a triangle is base times height divided by 2. And when we look at the area of the triangle up above here, our area would be 7 times 6 divided by 2, which would then be 42 divided by 2, or in other words, 21. Now, one of the neat things is you could see how this would occur if we were to take one side of this triangle and flip it around. For example, if I were to take the right-hand side of this triangle, which would have a bottom part of 3.5 if it was an isosceles triangle, and rotate it around to the other side, what you would see is the resulting figure on the bottom right. And then you would see that we actually have a rectangle that's being produced, and that rectangle would have an area of 3.5 times 6, or in other words, base times height. And also, in this case, you would see that that area would be a total of 21. And this is just an expression of how do we know that that original area formula for triangles was base times height divided by 2. It's because whenever you look at a rectangle and you split it in half, what you see is the result is a triangle, here shaded in red with a right angle. And so that's how they got the formula base times height divided by 2. In trapezoids, for similar reasons that are kind of explained in the diagram up above, they came up with another formula. And so the formula that they came up with, and I'm not going to go through the proof on this one, but the formula they came up with looks like this. The area of a trapezoid is equal to base 1 plus base 2 times the height, all of that divided by 2. So as we look at the trapezoid off to the bottom right here, what that means for us, if I'm looking at these, is to find the area, I would go base 1, which is 9, plus base 2, which is 7, all of that times the height, which is 6, and then divide all of that by 2. And so what ends up happening is you have 9 plus 7, which is 16, times 6, which is 96, divided by 2, which is 48. And so this is somewhat similar to, if you think about it, the area of a triangle where we did base times height divided by 2, but now there's another base, so you add that in there if that helps you remember. And again, there's pictures that kind of explain how they deduce this formula and everything. But the big idea is that I want you to remember that the formula is base 1 plus base 2 times the height divided by 2, area of a trapezoid. In our last slide, we're going to talk about areas of kites. And the formula for the area of a kite works like this. The area of a kite is diagonal 1 times diagonal 2 divided by 2. So in our particular case here, if we look at our diagonals, we have one diagonal here, and this diagonal has a total length of 8. We have the second diagonal here in the red, and this diagonal has a total length of 10. So in our particular case, what we would say is 8 times 10, divide that by 2, or in other words, our answer would be 40. Now, again, in the pictures, I tried to describe how they came up with this information and why it works. As you can see, they split the kite into two triangles, and with those two triangles, they put together the pieces, and that's how they discovered the formula. But what I really want you to know is that whenever they're talking about a kite, you can do diagonal 1 times diagonal 2, and then divide that by 2.